I have a question on the second core loading. I have a report here written by Phil Rutherford. Is Phil here? Okay. It said that the second core loading and the restart of the reactor was in 1963 of February, and in your handouts say that it occurred in 1960. That's my first question. Okay, and then I have a question on the cesium, which would have been Dr. Denning. You said there's no evidence that cesium was released, and I have data that 100% of the worker whole body counts showed cesium-137, 90% of the internal monitoring showed uranium and mixed fission products. So would this evidence in the workers' bodies be evidence of cesium releases?
You'd have to know the amounts because there was cesium from fallout on the ground, and so there would be uptake of that in anybody,
Well,
worker or non-worker.
Yeah, I don't know exactly what the amounts are, but I think this evidence is significant.
Okay, name is Abe Weisberg. I worked on the Hill from 62 to 65. Question for Tom and for the rest of the panel. When you were doing your numerology, Tom, you talked about the 30% and then the 20%, which got you to about 6%. And I think you're correctly addressing the starting point of all this is how much of the fission products could possibly have gotten out. And hopefully we can maybe get agreement from all of you that if the fuel didn't melt, then anything that was in the unmelted fuel wouldn't get out. I mean, I ran my own calculations considering the fact that the eutectic that everybody talks about is 6 uranium atoms per 1 iron atom, which would give you an ability to show exactly how much of the uranium fuel could melt. And I came up with about 1%. Paul said maybe 2%. Christian, who wrote a document that's in one of your 88 probably, came up with 0.65%. So I just wonder if among the three of you, you can reach agreement that if the fuel didn't melt, things didn't come out, and the maximum that could have come out compared to Lochbaum's 30% or whatever is somewhere in the range of 1 or 2%. So I think it would be helpful if there could be agreement, at least on this point.
I mean, I would agree that, and whether exactly what the number is isn't important, but it's in that range that it had to be molten, and as far as we can see here, it meant that it had to be eutectic, and that the iron didn't come down from the top of the cladding or up from the bottom or something like that to give you an enhanced amount. So there is some bound you can place on it, I think, along the lines that you guys are talking about.
That theory, I mean, on your estimate, I don't draw an important distinction between 0.6%, 1%, and 2%.
Right.
They're all the same in terms of what you're attempting to do, because the uncertainties are large.
Right.
I'm not willing to conclude that the amount of noble gases and volatiles in play could not be much larger, because I'm not willing to conclude that your analysis is the only analysis that could, or it's the only correct analysis. I'm not willing to conclude that your analysis, that it had to be eutectic melting, is correct. I look at, now I'm not a chemist, mind you, I look at the pictures, and I urge everyone to try to find the pictures. I would not conclude from that I'm at the 1% level. And also, I'm not sure your statement, in fact, I know your statement does not make a correction for where the failures occurred. but I don't think that's a big correction, but it's a small correction. But it's probably within that 0.6 to 2% range. But I'm not buying that it has to be in the 0.6 to 2% range only. I think that's kind of the lower bound that I've put on it, and there's an upper bound.
One, I would not think there's significant release unless the fuel melted. There's got to be liquefaction before significant release. If the fuel melted, the noble gases are going to get out, and that'll be the highest release. It also requires the fuel to melt to get the volatiles out, but the volatiles are going to be released less than the noble gases. And in these fuels, it would appear that they are significantly less based on chemistry. So when you look at that, I think the fuel melt is a good indication of what the upper bound of the release would be. And in this case, when I look at those pictures, I also see a messy fuel element, but I also see a lot of that fuel element that is not actually melted. There's a lot of locations where one could make an estimate of only a few percent of the entire fuel bundle melting. The one example that was done in 1960, they did assay, I think it was element number 24, and they looked at that element and tried to make an estimate of the total fuel steel alloy that was there. And the estimate was 800 grams, which would be about 1% of the total uranium in that fuel. That is probably not representative of the entire core. There's no way to say that. But the examples we have are that melt fraction is relatively low compared to the 30% of the fuels that was damaged. So I would come up with a number that was in the few percent range as a reasonable estimate, maybe a little less.
My name is Ed Schnabel. I worked on the Hill, and every single building on the Hill has electrician or electrical design. My question is very simple. Assuming that the noble gases carried off precipitate, which was radioactive cesium, iodine, how long would that be detectable in the buildings that I worked in?
If there were cesium and iodine that were released and contaminated those buildings, of course, some of these isotopes are short-lived, like iodine-131 is only 8 days. On the other hand, cesium-137 is 29, 30 years, I believe. So you should be able to see that contamination well after the accident.
No, I think that that's exactly right. But of course, if there was iodine release, look today and you're not going to find it. If there's cesium release, look today and it was significant, it would still be there, measurable.
I worked up on the Hill from 1961 to 2004, and I was involved in the re-instrumentation of the SRE after the incident. And while I started out work in the reactor physics group with the sodium graphite reactor, during the operation of that reactor, 2 times the air monitor went off. Once when the reactor was running, and the other time when it was down. And the source of the investigation of the source of the air monitor alarm was the Russian atmospheric test in Siberia. And at that time, they were worried about the whole dairy population of the western states. In your estimation, doesn't this sort of dwarf the result of any radiation going up the smokestack?
In that period of time, if my recollection is correct, by around 1964, the fallout from atmospheric nuclear weapons testing was giving doses in the northern hemisphere on the order of 4 or 5 milligrams. And if you use sort of current or even then risk estimates of what the added cancer risk and applied that to the population not only here, but across the northern hemisphere, you would get an enormous number of cancers because of the very large population exposed, which is why there was such an outcry in the 60s to stop atmospheric testing. Now, which they did. And now, it's a separate issue whether there was releases from this particular accident that were of the same magnitude or larger, and what the potential insult was. So I mean, I don't know where. By the way, when each of you said I worked on the Hill, where I live, when somebody says I worked on the Hill, it means I worked in the Congress. So. But I don't know where details of your particular cases that you're citing.
Dr. Denning, anything to add? Dr. Picard?
Well, compared to the direct release of virtually all fission products to the atmosphere in the atmospheric testing period, I guess I would have a hard time disagreeing with that was a much more significant.
Okay, thank you. My name is Dan Parks, and I worked up there shortly after about 1963. That would be a few years after the meltdown occurred. I worked in the health physics department, and I worked in nuclear operations. I just have about 3 questions I'd like to ask you guys. Many more, but I'll limit it to 3. Was any data given to you from Atomics International, or is everything you're talking about today just your theory? Was any logbooks made available to you, or documents, et cetera, so that you could extrapolate your information and make it more accurate?
I was given a CD with 80 documents on it that included, I think, some very significant documentation that one would want to understand what happened. I also asked for and received additional documentation, and I also got the benefit of talking to the other gentleman on the panel as we each went through this review. I would add, though, that I'm very troubled that Marcajani's analysis is unavailable. And if I were living in this area, I would work very hard. There's a library of documents at the site that is not available except to Boeing, and they're not well. I've been told by Phil that there's an access database that gives the title of each document, but essentially, and where it is in the library, but no other information. But that's a rich source of information, and it would be, and DOE is undertaking some effort to scan that information, but I think it ought to be moved off-site and made available as a library to people who live in this area and want to follow up on it.
So, just real quick, the specific question about logbooks. Can each of you address whether or not you looked at logbooks?
The reports that we were given in the 80 documents that Tom referred to, those are primarily published reports for the most part. They did not include logbooks or other less formal or published documentation.
If iodine had been released, wouldn't it have been as elemental iodine? And as the gases moved into the piping system and the holding tanks, it seems like it would have cooled off and condensed.
and there should have been a residual on subsequent days of higher releases earlier. And I'm just wondering if that's a plausible mechanism.
The progression of the accident would involve interaction with sodium, with the iodine before it got to the cover gas. So there's a good possibility that many of these fission products were in the form of iodides rather than elemental iodine. If there was elemental iodine, I think your scenario is right, that it would have plated iodine freezes at a fairly low temperature as soon as it got to cold surfaces. It would have tended to plate out or be residual. So, but I think the majority of these scenarios involve some interaction with the sodium and therefore mostly iodides rather than elemental iodine.
Yeah, I think if you speculate upon the release being elemental iodine, that if it trailed up in the bubble, and the bubble had sodium in it, you probably would have had a reaction to either sodium iodide or maybe cesium iodide. I don't think it changes your comment that it would have plated out someplace. Potentially could have been a particulate that hung around and was released with a gas. But I do think that before it got to the tank, it probably wouldn't be elemental iodine anymore.
My question is to all of the panel members. You've talked briefly about the fact that this is one accident among several. There's also 50 years of operations, burning operations, decladding at the hot lab that was nationwide. Nuclear materials were brought to the lab. So my question to each of you is, as the charge to look into these documents and analyze this particular accident in 1959 in July, what is your assessment of what that information provides to us as a community as far as understanding what our exposure is? If you are only looking at the one incident when there are 50 years of operations that may have released these contaminants to the surrounding environment, how are we able to put that into context? And then that second part of that is to please ask either Thomas Johnson or Tom Gallagher to please share with us what is the list of incidents, releases, and such that really should be in context. If we are to talk about radiological contamination of the area and the surrounding environment, we need to understand that perspective, and I would very much appreciate, while this is very important, we really need to understand that as well. So that is my question. Thank you.
It would seem that the course that's already been chartered by the EPA and DOE is the appropriate one. A very complete assessment of the radiological contamination in the area and the surrounding environment. It seemed like, I think that is something I heard described last time that I interacted with this, and it seemed like that's the appropriate activity to follow up with here. In terms of this, the amount of information that's in these documents, it is huge, but it also takes a lot of effort to mine that. I think it would take similar efforts to what we've gone through on many events. I think the EPA evaluation is going to be extremely valuable in saying, is there any of these other things that need to be looked at closer?
Well, I agree with Paul. There is an environmental impact statement process underway that provides the best hope for getting additional information that pulls all of the activities at the site together, both the nuclear and the non-nuclear. And frankly, I think the more important issue from the community standpoint is probably to follow the process of monitoring the site during and after the cleanup. And I would be more concerned about that than sort of this historical archaeology of what happened 50 years ago, which is not much you can do about in any case. But we do have a chance to ensure that there's proper site surveys of existing contamination during and after the cleanup, and I would focus on that.
My name's Barbara Johnson. I've spent the last 20 years as a member of the cleanup work group, and I have a general question for Mr. Denning, Dr. Denning, I'm sorry. You stated and Dr. Pickard intimated that there could have been no harm to the community. And I'm just wondering, if you think there was no harm to the community, why was this accident kept secret from the public for 20, 30 years?
First of all, based upon my analysis, I really do think this specific accident really could not have harmed the people. I can't speak about other things that have happened here at the site. With regards to the openness of the operators at that time, I think it's clear at that time they weren't very open about what happened. But with regards to the accident itself, to say that people didn't know about it, that absolutely is not true. That was in all the literature. I mean, I've got many documents, including the book that the quote was from, where there's a detailed discussion of the accident. So there really was a lot of information about the accident that was public knowledge. Although I recognize, I mean, one of the things that we read immediately following the accident, there was a statement that it's kind of like a TMI statements that we heard right after the TMI accident that said there was no fuel damage and there was no release and this kind of stuff. Clearly that wasn't true, and whether that was just their interpretation, I don't know. But I guess that, as far as publicly known information, there was a lot of information that really was that was out there and known and reported, certainly in all the technical meetings after this. People knew about the accident.
A couple of things you haven't discussed. We've discussed about noble gases and possible releases into the atmosphere and how they affected people. I'm wondering what happened to the sodium coolant. What did they do with that after this incident? We were just told that cesium can tie up with the sodium, and it occurs to me that one of the concerns we all have is it ended up at the sodium burn pit, and that's how a lot of the cesium-137 ended up around Area 4. Is that a correct assumption on our part, or do you have any knowledge about what happened to that liquid sodium in the reactor?
As I understand it, the sodium that was in the reactor at the time of the accident was continually processed over the next year, and that was the sodium that they started up again with the next year. Is anybody disagreeing with that? Okay. Some do, some don't. Yeah, at least that was in reports I had read, that the sodium that started up at Core 2 1 year later was there. But
Any,
Same sodium.
it was the same sodium. Yes, and that sodium still had some contamination in it, and I think in one report they actually had documented the level of cesium that was in that sodium at that later date. So, but I think that's about all I know. That kind of goes beyond what we were reviewing, but my impression was it was the same sodium. And of course, that was ultimately disposed of after the shutdown of the reactor.
Yeah, but you don't have any knowledge of how it was disposed of.
And I do not have knowledge.
Dr. Cochran?
Well, there is a sodium burn pit on the site. I don't know, and there is, we were shown another building that was a sodium research facility. I don't know how much of the sodium from the sodium reactor experiment was burned in the sodium burn pit.
None.
Okay.
Not what it was there for.
Okay. Well, good, we got some clarification.
My question specifically is to Dr. Cochran, and that is, you made the comment that
even by the standards of the day, but our safety standards were, I'm not sure whether they use the word appalling or something a little less. And the only, which is pretty strong, and the only evidence he quoted for that was that some guy had written a book or had, about designing a research reactor for MIT. And we have lots of people at AI that design research reactors, and so why does that make him any more authoritative than anybody else? And why do you make that statement?
Well, I said by today's standards, it would be considered appalling. I then said, I made a weaker statement with regard to the standards of the day, and I've written on page 2, and I refer you to page 2 of my written statement. I used, at least in the written statement, and I'll stand by that, unwarranted even by the standards of the day. And I quoted the former Atomic Energy Commissioner, who's also a former member of the Advisory Committee on Reactor Safeguards and a reactor designer. And beyond that, I have my own personal knowledge as a very young man in the 60s, but rather than rely on that, I chose to rely on the written statement of Tommy Thompson. And you may disagree, but I think the facts, we're really debating not what they did, but whether this was common behavior of the day. And I don't think it was so common.
Dr. Denning?
Yeah, I'd like to comment on this because I think that it is easy to be very critical here when there are a lot of very talented people that were safety conscious that were involved with design of not just this reactor but others at the same time. The thing that I think that strikes us as we look at what happened in this accident was that it was obvious that there were things that were going wrong that weren't understood. And this was more of an operational than a design thing with regards to the experiment. And it was an experimental program that was going on. And today, when you're dealing with nuclear, perhaps not within a proper perspective what the real risk is, but today everything has to be done with a high safety consciousness. At the time that this was happening, and it wasn't just a sodium reactor experiment, and that's why I think that it's particularly perhaps inappropriate for us to single out the sodium reactor experiment, but there was much more of a developmental aspect. That was that what was going on here was a development program, and if things went wrong, you just replaced them, and you just continued to work, and you evolved your design as a result of this. And so, and there wasn't the feeling, because it was a small reactor, that we were putting the people in the neighborhood at risk as a result of it. And as a result of this event, I think, although there might have been some risk, I think that it actually, didn't happen. But with regards to this question of was this common practice, if we look back at the same time period towards criticality accidents that were happening in the nuclear industry at laboratories, before 1960, there were a lot of individual criticality accidents that occurred as a result of people that were cavalier. I mean, the people that were threatened by it were themselves. I mean, the people that died in some of those criticality accidents were those people. And I think that it was just part of this, not recognizing that nuclear was something that was going to have to be treated specially different. So I think that's why when we look today within our perspective of what we see, the way nuclear activities have to be performed, they have to be planned well in advance. Anything goes wrong, you stop and you figure out what went wrong before you start up again. And what happened in this particular event was there were things going wrong that weren't well understood, and the plant just kind of worked through them, said, okay, well, we'll try this. We'll raise the temperatures, we'll jiggle the fuel, this kind of stuff. It just clearly isn't acceptable today. Whether it was generally acceptable at that time, it's marginal. But again, I think we have to be careful not to be critical of these very productive people that advanced the state of the art at that time, but within a different safety philosophy than we have now.
Just
Let me
one,
add one other.
quick, please. Okay.
When I was a health physics fellow beginning in 1962, it was beat into us the concept of ALARA, which is the concept called ALARA today, maintaining exposures as low as practicable was the term then. The health physics division on July 12th asked that this reactor be shut down until in light of the high releases to the high bay area on the 12th. And I think if they had operated the reactor subsequently in the manner that we were taught as health physicists, they would not have continued the operation beyond the 12th.
I first of all want to say how glad I am that you came here to help us with this issue. I'm glad to hear that the word meltdown is not the technical term because it's a term of alarm. And so partial meltdown I'll take, decladding of fuel rods I'll be happy with. The reason this is important to me is that, as you've read Dr. Lochbaum's and Dr. Bea's reports, people say this is the worst nuclear incident in the history of the United States. They say that
Respect the perspectives, please.
it's 250 to 450 times worse than 3 Mile Island. I would like to have a perspective because I'm concerned about my community. The fear of this one specific incident. I'm not saying the rest of the site's not contaminated, but I would like you guys to explain to me the relationship of this incident in the scheme of nuclear reactor incidents. Put it in perspective for me, and again, would you please reiterate that you don't think that it caused any harm off-site to anybody besides the workers? And I should add, how many former workers on the SRE have you been able to interview?
Well, I think the accident, there's an obvious comparison with this 3 Mile Island accident, and I think that I think the release that occurred at 3 Mile Island was substantially greater than the release that occurred here, and yet I think that there still was no significant increase in risk at 3 Mile Island as a result. But I think that one thing that you need in the perspective is the difference in the potential hazard. As a 20 megawatt thermal reactor, the potential here was never really as high as it was at 3 Mile Island. And so I think that as far as we who are involved in reactor safety business, 3 Mile Island was the most important accident that happened. I think that probably the Browns Ferry fire was probably the second most important accident that happened, even though there's really no external release, just because of the potential and the lessons learned. I think that that looking back at the importance of accidents, that the safety culture that existed here was extremely poor, but because there wasn't the magnitude of potential, the community didn't look at it and analyze it and say, you know, we have to really change the way we do business, as we realized at the 3 Mile Island accident. So I guess those are the perspectives I would have. Radiologically, I think this was a less severe accident than the 3 Mile Island accident. Neither one of them were great. The potential 3 Mile Island was certainly much greater than the potential that ever existed here. But both of them were severe examples of safety culture issues.
Dr. Cochran?
Well, I would just add there was one nuclear accident that was much worse than 3 Mile Island, and that was Chernobyl. There was a research reactor accident at Idaho, that SL1, that killed one or two individuals, three individuals. So in terms of occupational hazards, that was worse than this one. On the 3 Mile Island accident, because of the number of factors, including the secondary containment, there were releases, and various people have estimated the impact of those, estimated the releases and their impact. And if you took the Nuclear Regulatory Commission's estimate of the releases and applied the National Academy of Sciences BEER 7 risk estimates, you would say there was sufficient release for there to be on the order of one, and I'm using order of magnitude, on the order of one cancer in the population, but on an individual risk, it would have been not significant in my view. In this particular case, I've said what I thought as far as I could go, and I haven't done any calculations, and so I wouldn't speculate on the quantitatively the number of statistical cancers one would calculate in the population if one knew the releases, and I don't know the releases.
Real quickly, Dr. Picard, if you have anything to add.
Yeah, I certainly agree that this accident, in comparison with these major accidents from nuclear plants with much larger sizes, much larger inventories, is not a major factor in the overall impact on the community. That being said, the small research reactors, the sodium reactors that we've had in this country and in others, have had a fairly difficult record of safety. These are first-of-a-kind reactors with new features. We have, as a community, not done real well in anticipating what those things are before they happen. So the sodium reactor story is one of significant problems on the way through, and that could be because primarily the technology is new. It is much more sophisticated than water reactors, but the history has not been exemplary here.